Have you ever gazed up at the sky and wondered what lies between the ground beneath your feet and the infinite darkness of space above? What if you could take a journey that begins on the solid, familiar surface of the Earth and ascends higher and higher, passing through unseen realms where storms brew, stars shimmer, and the universe begins to whisper its secrets? This isn't just a journey through distance. This is a voyage through the layers that make up our planet's atmosphere, each one a mysterious, vital part of life as we know it. Ever wondered what's up there that we can't see? I'm Umbra, and I'll reveal it all. Keep watching. The Troposphere, life's weather engine, 0 to 12 kilometers. Our journey begins right where we stand in the troposphere, the lowest and most familiar layer of the Earth's atmosphere. This is the stage for everything we associate with daily life. The cool breeze that rustles through the trees, the clouds that roll and shift, the rain that nourishes the ground, and the storms that light up the sky with electric fury. It's a chaotic and vibrant place, alive with motion and energy. The troposphere stretches roughly 12 kilometers above the Earth's surface, but don't let that modest height fool you. This layer is the powerhouse of weather. From gentle drizzles to ferocious hurricanes, the troposphere is where the atmosphere interacts directly with the planet's surface. Sunlight heats the ground, causing warm air to rise and cold air to sink, creating the swirling patterns of wind and weather that govern our days. Here we live and breathe, where mountains stand tall and oceans stretch endlessly. As we ascend through this layer, the temperature begins to drop sharply. For every kilometer we climb, the air grows colder and thinner. At first we might see familiar sights, the city skyline below, highways dotted with cars, and green fields stretching into the distance. But as we climb higher, these details blur, replaced by a patchwork of shapes and colors, until finally the horizon curves ever so slightly. Airplanes cruise through the upper reaches of the troposphere, soaring above the clouds where sunlight glints off their wings. Beyond this point lies the edge of the familiar, a gateway to the unknown. The Stratosphere, the protective shield, 12 to 50 kilometers. Crossing into the Stratosphere feels like entering a realm of calm after the turbulence of the troposphere. Here, at heights between 12 and 50 kilometers, the air is remarkably stable. This is the layer where jet planes and weather balloons glide effortlessly, navigating the smooth currents of this atmospheric highway. But the Stratosphere is more than just a serene layer. It's a shield that safeguards life on Earth. Suspended within its upper reaches lies the ozone layer, a thin yet vital barrier that absorbs and filters harmful ultraviolet UV radiation from the sun. Without the ozone layer, the sun's searing rays would wreak havoc on our planet, rendering it inhospitable to life. It's humbling to realize how this invisible shield works tirelessly above us, unseen but essential. The Stratosphere is also unique in how it defies the typical rules of atmospheric temperature. Unlike the troposphere, where temperatures decrease as we ascend, the Stratosphere grows warmer the higher we climb. This warming is due to the absorption of UV radiation by ozone molecules, creating a layer that feels almost like a thermal blanket. Looking out from this height, the Earth begins to look like a vast curved mosaic. The atmosphere's blue fades ever so slightly, and the sun shines with a clarity that feels almost otherworldly. We're no longer in everyday weather. Here, the winds are steady, the air is thin, and the boundaries of Earth's protective layers start to reveal themselves. The mesosphere, where meteors burn, 50 to 85 kilometers. As we leave the Stratosphere behind and ascend into the mesosphere, we cross into one of the most mysterious and least explored layers of Earth's atmosphere. The mesosphere stretches from 50 to 85 kilometers above the surface, and it is here that the atmosphere becomes a graveyard for meteoroids. Every day, countless meteoroids hurtle toward Earth, fragments of rock and debris left over from the birth of the solar system. When these fiery visitors hit the mesosphere, they encounter resistance from the air molecules, causing them to heat up and burn brightly. These streaks of light, known as meteors or shooting stars, are a mesmerizing reminder of the dynamic interplay between Earth and the cosmos. Despite its fiery role in protecting Earth, the mesosphere is the coldest layer of the atmosphere. Temperatures here can plummet to a bone-chilling -90 degrees Celsius. The air is so thin that it would be impossible to breathe, yet it remains dense enough to destroy most meteoroids before they can reach the ground. At this height, the Earth below begins to look like a shimmering blue sphere wrapped in a delicate veil of atmosphere. Above us, the sky darkens, transitioning from a soft blue to an inky black. It's a realm of extremes where fire and ice coexist in a delicate balance, reminding us of the forces at play in our planet's upper atmosphere. The Thermosphere, dancing lights and spacecraft 85 to 600 kilometers. Climbing higher still, we enter the Thermosphere, a layer that stretches from 85 to 600 kilometers above the Earth's surface. This is where the atmosphere begins to merge with the vacuum of space, and it is a place of breathtaking beauty and technological marvel. The Thermosphere is where the auroras, nature's most dazzling light displays, come to life. Charged particles from the sun collide with gases in the thermosphere, creating brilliant curtains of light that ripple and dance across the polar skies. The aurora borealis in the northern hemisphere and the aurora australis in the southern hemisphere are living, breathing phenomena that connect Earth to the sun in a stunningly visual way. This is also the layer where human ingenuity has reached its zenith. The International Space Station orbits within the thermosphere, a marvel of engineering and collaboration that serves as a home and laboratory for astronauts. Space shuttles and other spacecraft pass through this layer on their way to orbit, using its thin atmosphere to their advantage during re-entry. Temperatures in the thermosphere can soar to thousands of degrees Celsius, but it doesn't feel hot in the way we experience heat. The air is so sparse that there aren't enough molecules to transfer heat to objects, creating an environment that is both scorching and frigid, depending on perspective. From this vantage point, the Earth appears as a luminous jewel, its surface glowing with the light of cities and the reflection of the sun. The boundary between Earth and space is tantalizingly close, just beyond the reach of the thermosphere's outer edges. The Exosphere, the final frontier, 600 kilometers and above. At last, we reach the Exosphere, the outermost layer of Earth's atmosphere and the threshold of space itself. Here, the air is so thin that individual gas molecules can travel hundreds of kilometers without colliding with one another. Gravity's pull weakens, and the atmosphere gradually fades into the vacuum of space. The Exosphere is home to satellites that orbit the Earth, silently relaying signals for communication, navigation, and observation. It's a quiet, isolated place where the planet's protective embrace gives way to the vast emptiness of the cosmos. Looking back from this height, the Earth is a breathtaking sight. A sphere of blue and white, cradled in the blackness of space, it is at once magnificent and fragile. From this perspective, it's easy to see how interconnected everything is, how thin and delicate the layers of the atmosphere are, and how precious life on Earth truly is. Leaving the Exosphere, entering space. As we rise beyond the Exosphere, the final whisper of Earth's atmosphere fades entirely. We are now in the realm of space, a silent, infinite void speckled with stars, galaxies, and mysteries beyond comprehension. The boundary between the Exosphere and space isn't a sudden line, but rather a gradual transition. Known as the Kármán line, it's generally accepted to be around 100 kilometers above Earth. Here, the rules of physics shift. Gravity still exerts its pull, but the sensation of weightlessness takes over. We've officially crossed into outer space. From this vantage point, the Earth below appears suspended in time, its vibrant blues and greens contrasted against the deep black of the cosmos. It's a perspective that few have experienced firsthand, but those who have described it as life-changing. This is the overview effect, a profound connection to our planet and a newfound appreciation for its fragility. But our journey doesn't stop here. Space is boundless, and as we continue our ascent, we begin to explore the forces that govern not just Earth, but the universe itself. The Earth's magnetosphere, the cosmic guardian. Even as we leave the visible layers of Earth's atmosphere behind, the planet continues to exert its influence. Extending far into space is the magnetosphere, a protective bubble generated by Earth's magnetic field. Invisible yet incredibly powerful, the magnetosphere shields the planet from harmful solar wind and cosmic radiation. Without it, life as we know it wouldn't exist. As we move deeper into this region, we encounter the Van Allen radiation belts, two donut-shaped zones of charged particles trapped by Earth's magnetic field. These belts act as a dynamic barrier, deflecting high-energy particles from the sun. However, these particles can interact with Earth's atmosphere during intense solar activity to create geomagnetic storms. Such events can disrupt satellites and power grids, but also contribute to the awe-inspiring auroras we saw earlier. Traveling through the magnetosphere reminds us that Earth is not an isolated entity. It is part of a vast cosmic network, shaped by and interacting with the forces of the sun and beyond. The Moon, Earth's celestial neighbor. As we move farther from Earth, the Moon becomes our closest and most immediate destination. Its cratered surface reflects the sun's light, illuminating the night sky and serving as a constant reminder of Earth's place in the cosmos. The Moon is not just a lifeless rock, it holds the story of our solar system's history. Its surface is scarred by billions of years of impacts, a record of cosmic events that have shaped the planets and moons. The moon's gravitational pull profoundly influences life on Earth. It drives the tides, stabilizes Earth's rotation, and plays a role in maintaining the delicate balance that makes our planet habitable. As we imagine standing on its surface, looking back at the Earth hanging in the sky, we gain a new perspective on the interconnectedness of all things. The moon also represents humanity's first steps into space exploration. The Apollo missions of the 20th century proved that reaching beyond Earth is possible, inspiring generations to dream of new frontiers. Today, the moon is a symbol of both what we've achieved and what lies ahead. Beyond the moon, the solar system beckons. As we continue outward, the sun becomes the dominant force in our journey. It is the heart of our solar system, a massive ball of nuclear fusion that provides the energy for life on Earth. Its light takes approximately 8 minutes to reach our planet, traveling across the vacuum of space at the speed of light. 8 planets orbit the sun, each with its own unique characteristics. Closest to the sun is Mercury, a scorched and cratered world. Venus's thick, toxic atmosphere is both a cautionary tale and a scientific curiosity. Beyond Earth lies Mars, the red planet that has captured humanity's imagination as a potential second home. The gas giants, Jupiter and Saturn, are next. Their immense sizes and swirling storms make them some of the most visually striking objects in the solar system. Saturn's rings, composed of ice and rock, remind us of the delicate balance of gravitational forces at play. Farther still are Uranus and Neptune, the ice giants, with their mysterious compositions and distant orbits. Our solar system is vast, but it is only one of billions within the Milky Way galaxy. As we journey farther, we begin to grasp the true scale of the universe. The interstellar frontier. Exiting the boundaries of the solar system, we enter interstellar space. Here, the influence of the sun's gravity and solar wind fades, replaced by the faint remnants of material from distant stars. This is the realm of the Voyager spacecraft, humanity's farthest-reaching explorers. Launched in the late 1970s, Voyager 1 and 2 continue to send back data, carrying with them golden records, time capsules of Earth's culture, sounds, and images meant to communicate with any intelligent life that might one day find them. Interstellar space is unimaginably vast. The nearest star system, Alpha Centauri, lies over 4 light-years away. Traveling at the speed of the fastest spacecraft we've built, it would take tens of thousands of years to reach it. Yet even this immense distance is only a fraction of the universe's scale. The universe, a vast and unfathomable expanse. As we look farther into the cosmos, the universe unfolds in layers of complexity and wonder. Galaxies, collections of billions of stars, planets, and dust, stretch across the fabric of space, bound together by gravity. The Milky Way is our home galaxy, a sprawling spiral of stars that contains our sun and countless others. Beyond our galaxy lies a cosmic web of interconnected structures, where clusters of galaxies form filaments and voids. The universe is not static, it is expanding, a fact first discovered in the early 20th century. This expansion, driven by a mysterious force called dark energy, raises profound questions about the origins and fate of the cosmos. The more we explore, the more we realize how little we truly know. What lies beyond the observable universe? Are there other dimensions, parallel realities, or unknown forces shaping existence? Each discovery opens the door to new mysteries, reminding us of the infinite possibilities that lie beyond our current understanding. Traveling through the Earth's layers and into space is an incredible adventure. Each layer, from the busy troposphere where life happens to the quiet exosphere where space begins, plays a vital role in protecting and supporting life on Earth. Beyond these layers, as we explore the moon, the planets, and the stars, we realize how unique and precious our planet is. Looking back at Earth from the vastness of space reminds us how small we are in the universe, yet how unique our home is. This journey isn't just about understanding the atmosphere or space. It's about appreciating our fantastic world and being curious about the endless wonders beyond it. Let's never stop exploring and learning about this beautiful, mysterious universe.